students. So we are going to start with the next chapter, that is surface area volume, which is very interesting as we have already learned in standard 7, standard 8 and 9, and now we are coming to 10th standard, one step ahead. In this 10th we are going to learn the combination of solids, how to find for the combination of solids area and its volume. Okay, so let's start going. So here we know surface area volume. What is area? Surface area. Surface area is nothing but the area that is covered, or we can say region that is occupied by the surface of an object. A simple example, when you buy a gift, any gift, we wrap it. Okay, so we go for gift wrapping the paper. So the paper is covering the whole surface of the gift. Okay, whether it's a rectangular shape or whatever is it, so it is covering. So that is the area that is occupied by that gift, whatever is there. Suppose it's a rectangular shape, so the rectangle that is occupying the whole cover, the paper, that is called the area occupied. If you're going to buy a carpet for your house, so the area, so you measure the area of the floor. So how much area is the floor, that much carpet you will buy. So that is the area that is occupied by that surface. Okay. Then volume, you all know, that is the amount of space that is being occupied, or we say in simple terms, volume means the capacity of an object, that is said to be volume. Okay, so let's go in. When we start with this, we know that it's a combination of solids. So we have a combination of actually cuboid, cube, cylinder, cone, sphere and hemisphere. Only this combination. So as I said, it's just a recap, right? So we have already learned. So let's have a quick recap. So first, TSA. TSA means total surface area. LSA means lateral surface area. We can use short form even in the board exam. Then we know volume. Okay. So when I say total surface area, just now I said when you have to gift wrap, suppose a cuboid. Okay, so we know how much paper is required to cover the whole surface. Okay, surface which we can touch. So whole surface. So here we know this is L, this is breadth and this is height. This is L, this is breadth and this is height. So when you want to calculate the total surface area, a quick thing, here we know this area. Okay, we know that the parallel surfaces are equal. So if I say this surface and this surface are equal. So what is the area of this? Is a rectangular shape. This is LH. So this is also LH. Coming to this space here, this particular area, this is B and this is H. So this is the area, you know that area of a rectangle is length into width. So here in this case it is B and this is H. So this is BH. So here BH will be 2BH. Similarly, the upper, which I have just done the strokes I have just made. This is L, this is B. So this is LB, this is LB. So this LB plus LB will be 2LB. So TSA of the formula, TSA of the cuboid is 2LB plus 2DH plus 2HL. So if you take 2 common, so you get 2 into LB plus BH plus HL. That is total surface area. When we say LSA, lateral surface area, it literally means that we don't consider the upper base and the lower base. The both base are, right, only the 4-sided are considered. Lateral surface area, I repeat, only the 4 surfaces is considered, the one with the vertical faces. Okay, the upper portion is removed and the lower portion is not considered. The upper part and the lower part is not considered. Only the 4 walls we can say. When I say cubidical room, so only the 4 walls. Okay, so lateral surface area. So when we don't consider this, so that means LB and LB is not considered. So 2LB is removed from this TSA. So we have the formula 2LH plus 2BH. If I take H common, so this is actually the formula. LSA formula, if we say 2LH plus 2BH or 2BH plus 2LH. Correct? But if I want to simplify a little further, so to get, can we derive more formula? Can we derive something else from this formula? Yes. If I take H common, I'll get 2L plus 2B. Now 2L plus 2B is nothing but it is the formula for the perimeter of the base. Perimeter of the base of a rectangle is nothing but 2L plus 2B, right? So here I can also write this formula as H into perimeter of the base. Okay. So LSA formula is 2LH plus 2BH, which can also be simplified as H into perimeter of base. we all know volume formula when you derive, it is nothing but area of the base into height. That is the standard formula for volume of the object. So here the base is L and B. So here LB into height. So the formula for volume of a cuboid is L into B into H. Okay. You all know cube. So when cube comes, what things comes into mind? Ice cube, Rubik's cube and a dice. Okay. So when you have a cube, we all know that length, breadth and height are equal. So simply instead of L, B and B, H and H, we will just substitute one letter, that is side. So either you can take L, you can take A. So I have taken A just to avoid confusion. So I will assume let the side of each cube be A. So each side A. So we know that there are 6 faces. There are total 6 faces. So here we A square, A square, A square, A square, A square. So how many A square will come? 6A square. Or simply here you can substitute A into A, A into A, A into A. So A into A square plus A square plus A square. So A square plus A square plus A square, 3A square. So 3A square plus 2 will give you 6A square. Similarly for LSA. So for LSA, we don't consider the top. We don't consider the base. Top base and the lower base we don't consider. So how many sides for A square, A square, A square, A square. So it's 4A square, right? Or simply substitute here A into A. So 2 into A square plus 2 into A square, 4A square. Volume formula we all know, that is L into B into H. So A into A into A, it will give you A cube. Did you understand? Coming to cylinder part, students. Now we know that the cylinder is actually made up of a rectangular paper. So we all know. So they have taken a rectangular paper. Okay. Now with the help of this, when I fold the end, now here I am folding this rectangle along the lengthwise. Along the lengthwise, if I am folding, I am getting, okay. So if I stick it, I get a cylinder. So rectangle here we get with the help when folding a rectangle, we get a rectangular sheet of paper, we get a cylinder. Now here we don't have cylinder, we don't have lateral surface area. We talk only about curved surface area. Okay, I hope you have understood that is only curved surface area. So this one, if I want to find quickly, I just explain. This is CSA if I want, that is curved surface area. We all know that here, this when I remove, this is a rectangular page and the formula for area of rectangle is length into breadth. Length into breadth. Okay. So when I fold this rectangle along the length, I get a cylinder. Now here this cylinder, this is my height. Sorry, this is cylinder's height. This is cylinder's height. And here what you get, that is a circle. We know the base of the cylinder is always a circle. The base and the top of the cylinder is a circle. Now in this cylinder we can find, students, this cylinder, we can find that this is nothing but the circumference. This is the circumference of the cylinder and this is the height of the cylinder. This is the circumference of the cylinder and this is the height of the cylinder. We all know that circumference of a circle is nothing but 2 pi r. Okay, this is 2 pi r and this is h. So when I remove this, actually we require the CSA, curved surface area cylinder. So this is actually when I fold along the length, you have seen this forms the CSA, this forms your 2 pi r and this is h. So what is the formula for CSA of a cylinder? 2 pi r h, because area of the rectangle is nothing but this is forming 2 pi r, this is 2 pi r and this is h. So 2 pi r into h will give you the CSA of the cylinder. I hope you have understood. So this is 2 pi r, which is 4. So this is 2 pi r, this is h, and area of rectangle formula is length into breadth. So here we know that CSA of the cylinder formula is 2 pi r h. So whenever you calculate radius, we all know radius deals with only circles from here. And this is a right circular cylinder. So right circular cylinder, what do you mean by the word right circular cylinder? It will always be this vertex, this center will be always be perpendicular. So it is a right circular cylinder. You cannot have ding dong ding cylinder. It will be a straight cylinder. So we call it as right circular cylinder. So here 2 pi r h. When we say total surface area of a cylinder, so we assume that it has a lid. It has a lid, top also it is covered and down also it is covered. And we know that circle formula is pi r square. So how many circle? Here we have pi r square and here also be pi r square. So TS is calculated as CSA plus the area of the bases. And we have 2 base, so 2 pi r square. So 2 pi r h. TSA is nothing but CSA plus the area of the base is 2 pi r h plus 2 pi r square. So when you take common, 2 pi r is common, so h plus r. So either we can say 2 pi r into h plus r or 2 pi r into r plus h. Coming to next, volume. Now volume of cylinder, again I said volume formula we can say area of the base into height. Area of the base into height. So what is area of the base here? Pi r square, and height is pi h. So volume formula is pi r square h. Okay. Let's come to cone. So when we talk about cone here, so again a cone is a right circular cone. So here we can see the center is perpendicular here. Here we can see that the tip or the vertex of this cone will be exactly perpendicular to the center. So it's a right circular cone we say. So when we draw, we get actually a right angle triangle. Okay. So when we talk about CSA in the cone, we have R, we have H, we also have this height that is called a slant height. Actually, now I will not go in the derivation of a cone, but I will just tell you that if you cut the sector of a circle, you have learned the sector, okay? So from a circle, if I cut a sector and if we join the step ring portion, that means if I join this OA and OB, I get my cone. The cone is ready, okay? So this is actually R, okay? Which when we fold it, it becomes L. So this is L, this is R, this is H. Okay. So CSA of a cone formula is pi RL. CSA formula is pi RL. Now when we talk about this formulas, it is the derivation you must have learned already, that we just can divide the sector into small right angle triangles. Each right angle triangle, and if I join it, when you find the area of the whole triangle, right, the formula will give us pi RL. Where this L formula is actually Pythagoras theorem. We know that L square is R square plus H square. So L equals to square root of R square plus H square. Similarly, TSA, we assume Cornetto ice cream, that cone when we say. So the lid, it is there. So TSA is fully covered, the base is covered. So TSA of a cone is CSA plus area of the base. So CSA plus area of the base is pi RL plus pi r square. Okay, so here you find that here there is no LSA. Here we have CSA, curved, because it is curved surface area. So pi RL plus pi r square, we take pi r common, so we get pi RL plus r. Coming to volume of a cone, we know there is a beautiful relation of a cylinder and a cone. That cylinder here, volume of the cone is 1/3 of volume of cylinder, or we can say volume of cylinder is 3 times the volume of cone. You must be knowing this. Volume of cylinder is 3 times the volume of the cone. The cylinder is bigger. So volume of cone will become, it is 1/3 of the volume of cylinder. Volume of cylinder is pi r square h. So volume of cone is 1/3 pi r square h. Correct? So I got an example of a cylinder. So this is an example for a hollow cylinder. We all know, okay, as we have a hollow pipe. Coming to the next, we go for sphere. Okay, the best example you must have seen, that is, this is actually a solid sphere. It's not a hollow sphere. Okay, so ball, you can take an example. The shot put is an example for a solid sphere where it's very heavy to carry. So we will deal with mostly solid sphere. Okay, and if you have a hollow sphere, then we know that thickness, everything comes into role when you have R and H. Correct? So we'll go to the hollow part also. Let's do first now sphere. Okay, so for the sphere we have, now as I have taken a circle shape. So here we say CSA and TSA remains the same, as we don't have a different, all the surface is circle. Okay, so we don't have LSA or TSA. So as it is, every side it is similar in everywhere when you say it's similar. So CSA or TSA. So if the word surface area is mentioned, of a sphere, it is actually TSA, CSA same. So the formula is 4 pi r square. And this derivation also you must have learned in the 9th standard, that if you take a wool and if you try to cover the whole ball, take a ball, any plastic ball, and you just insert a pin and you try to cover the whole surface with the woolen thread, and when you again entangle it, remove that thread, and if you see, it will fix actually 4 circles of the same radius. So we will not go deep into it. So the formula is 4 pi r square. Similarly, volume formula is 4 upon 3 pi r cube. I will explain this relation after explaining the hemisphere. So the formula at present we know the formula is 4 upon 3 pi r cube. Coming to hemisphere. Now when I say total surface area is same and volume is the same, what is the capacity? What is the mass present in that volume? So volume 4 upon 3 pi r cube. When I say hemisphere, so I have just taken a small example here. This is just a coconut half shell. So best example for coconut, and here you have thickness. As I said, hollow part also we will do. So here there's a hollow hemisphere. A hemisphere and with a thickness. So hollow hemisphere, right? So here when we have a hemisphere, here we can say CSA. So the CSA formula is nothing but only this outer portion, the CSA. Here we have two surfaces because we have the curved portion and we have the, for example, you have, it is covered. If the lid is covered, then we say TSA. If I say only CSA, only means outer portion here, if I consider, so half of this 4 pi r square will give you 2 pi r square. And if I want to find the total surface area, it is nothing but CSA plus the area of the base. So area of the base is nothing but pi r square. So 2 pi r square plus pi r square will give you 3 pi r square. And then the volume formula of the hemisphere, it is half of this. Half of this. So 4 upon 3 pi r cube, half of this will be 2 upon 3 pi r cube. So if I divide this by 2, so I'll get 4 upon 3 pi r cube. If I divide by 2, say by 2, so I'll get this is 2 upon 3 pi r cube. So I'll just explain the relation of these formulas also. So actually this formula, practically also actually we can derive this formula, how this formula has come. Find the capacity, that is the volume of the sphere. Okay, by Archimedes principle we can actually derive the formula and find the formula for volume of the sphere. Suppose if you take a cylinder, fill it with water. Okay, so for example I just say this is suppose 50 ml of water is, it's calibrated 50 ml. Now you just put the sphere inside, suspend the thread. Now what will happen automatically from here? Now the water will increase. So water will increase. So let this rise be this. Okay, suppose this is 10 ml. Now this 10 ml rise has become because, okay, I will not say 10 ml, I have said the answer directly. Suppose now it has raised to, now here it is 60 ml. So if this water rise, which is I have drawn in the green color, this rises because of this sphere which has been immersed. So if I want to find the volume, so volume is nothing but 60 ml minus 50 ml, that is 10, we can say the 10 ml, we can say, and then we can convert it, right? So this way practically also we can find out, and then we say the formula is nothing but 4 upon 3 pi r cube, the volume of the sphere. Also we can derive, there is a relation between the volume of cylinder, and there is a relation between volume of cone. We all know volume of cylinder, volume cone, and also between volume of sphere. So if I want to explain this, we know that if you just take a cylinder, a cone, I have taken cylinder, cone, and just I say a sphere. So I have taken three cylinder, cone, just to derive the formula and quickly explain. So if you have cylinder, cone and sphere of the same radius, please don't ignore my diagram, it's not that neat. Okay, so if you take a cylinder with a bottom, okay, cylinder, cone and sphere of the same radius and height also same, okay, the height is also same. So if the height is same, and here I assume the height is same, then we can definitely find the relation. How, if I say, suppose I take the cone, we already know the relation. Just to explain this formula, if I try to use this cone and here I am just inverting, so I fill with the sand, okay, and after filling the sand, that means here first condition as I said, all the three should be of the same radius and same height. The height also should be same, okay. So I fill this cone with the sand and I pour in it, and then I do a marking. Let's assume this. So here I have done a marking and I find that it is covering the first part this much. Okay, then again I filled up to the brim. Brim means till the full, and then again find the second time also it fills, and this is the second marking. So this is the first marking, second time, and sorry, I'll just take it a little up. And the third part, when I feel that the whole cylinder has been filled. And so we say the relation that volume of cylinder is nothing but 3 times of the volume of cone. So 3 times when I fill this, I find that my cylinder is filled. So we get the formula that volume of cylinder is nothing but 3 into volume of cone. Correct? 3 times when I fill, I get this. Now similarly, if I try to fill this sphere, okay, suppose I have an opening and I fill with this sand and try to fill it, what will you get? Now suppose I draw here, so that's a better understanding. Same, we'll assume the same. So when I fill this sphere, I find that here there are 3 markings. I'll just divide into 3 parts. Here first part, second part and third part, what I said, first, second, third. So when I fill this with the sand and fill, I find that it is covering the smush. That is, it is covering the 2/3. 2/3 is covered by the sphere with only one time you fill. With one time you just fill the sphere with the cylinder. That means you are filling the sand in the sphere and you're pouring inside this. You find that 2/3 of the portion of this cylinder is covered. Okay, so there is a relation. What we can say here, we can say volume of the sphere is nothing but it is 2/3 of the cylinder. 2/3 of the cylinder. Or we can say that here we can say here 2/3 of the cylinder is filled by this volume of the sphere. One time that is 2/3 of the cylinder. Or I can say this is covered. Here we can say a cone, it is filling half the time. Here the sphere, when I say sphere here, this is when you are pouring one time here, it is doing 2 times. So here when I say volume of cone is half of volume of sphere. Let's understand this relation. Can we say this is volume of cone is half the volume of the sphere? That means it is twice it is filling, right? So twice of the volume of the sphere. So here if I want to derive the formula half, here you know volume of sphere we have to find, right? So here it is twice the volume of cone is nothing but volume of sphere. This also I can say. So volume of cone formula is 1/3 pi r square h. 1/3 pi r square h. Okay. So 2 into volume of cone is volume of sphere. 2 into volume of cone is volume of sphere. Here we get, here okay, so when we write here 2/3 pi r, now here we know that here height of the cone, I have to derive the volume of the sphere in terms of only radius. Okay, so here height is nothing but twice of the radius. H is nothing but 2r. Whenever we talk about the height of a sphere, it is nothing but the diameter, and diameter is 2r. So we will never have height of the radius, height of a sphere. Everything will be in the terms of r. So here when I substitute instead of h, see here I have written 2/3 pi. Here I will write 2r. So I will get a relation that is 4/3 pi r cube. So we get volume of sphere formula is 4/3 pi r cube. From here also derive the same thing. The volume of sphere is 2/3 of the volume of cylinder. So here if I substitute 2/3, volume of cylinder is pi r square h. So 2/3, as I said, again this height we will write as 2r. So again we will get the same formula, that is 4/3 pi r cube. So when we talk about relation of a cone, cylinder, cone and sphere, it is always the relation is 3:1:2.